Hi everyone, hope you are doing good. So this slide is based on observation of our project, that is paper plane launcher. So here we begin. So my name is Anushka Saxena and I am a member of Group 6 from NAT 108 NBA section. So in this slide we will talk about the observation that we have made while performing our project of NAT, that was paper plane launcher. So here we will talk about all the observation that we took and how it worked. First of all, it begins with what is observation. So, according to scientific experiments, observation is one of the most important part as it tells us how our project is working and how our project is and whether it can relate to fact or have some troubles that need to be eliminated. So here is a video that me and my friend recorded while performing our project. As you can see that I used a board as well as a needles as well as the rubber band and an airplane. So I stretched the airplane and shoot it. So it launched and it went through some direction in as well as some distance, so we measure that distance. So in the next slide I will discuss what materials are used and how errors can come from those materials. So here are some mentioned materials that have been mentioned before also, but I have mentioned it to just make it clear, like while performing my experiment, what are the things that I'm using. So as in the first image, you can see that it is an airplane, of course, for launching a plane, of course I have to make a plane. Then there is a tape. The inch tape, a measurement tape that we use while measuring the distance, like whatever distance our plane traveled, like how much distance it launched when we launched it, how much distance it moved. So we use that measurement tape. Then I have a board, like this board I used as can say a platform from where I launched my plane. So I need this platform because I have to fix my needles inside them, as well as I use a rubber band so they can produce some elasticity while launching my airplane, as well as for launching the plane I need some equipment, I need some hook that can just get into the rubber band from which I can stretch it, so I use that too. So the main motive of this slide is about observation, and observation comes when we take reading of our assignment of our project that we perform. So here are the real observations that we got while performing the experiment. So me and my friends took exact 4 readings. So we tried approximation, like from the place where we launched the plane and the place where the plane dropped. So in first reading we got 27 inches, as we were measuring the distance in inches, we were using an inch tape. In the second reading we got 26.5, third there was a drastic change, that was 66.2, and the fourth reading it was 31.5 inches. So these are the observations, this is the table in which I mentioned each and everything. As making a table is one of the important part of observation, of mentioning each and every steps, like what are the reading that you got. So this is the main part of this slide. So while creating this slide, I took some examples that my professor provided in the PDFs. So to be considered good science, an experiment must contain these steps, which are like 4 must steps. To must keep track of information by recording the data and present visually through a graph table, and must use a control to compare results against a baseline, as well as must draw a conclusion from the result and must report errors. So I have mentioned these points in the rest of the slides, so we will see them. Graph presenting distance traveled by plane. So as there's a must step where it says that there should be a visual presentation of our observation. So here I made a line chart which is presenting like how the rating fluctuated. Like at first it was somewhere between 20 to 30, nearby 30. In second reading it was somewhere below the first reading. In third it was huge peak, and at fourth it came down. So here's a line chart, or I can say a visual representation of my observations. The other must step contains mentioning the reasons that can produce errors. So as you can see while watching the view of the line chart, that there was a change while recording the experiment. So why those changes occurred? like something is there, because we are performing the experiment the same way we are doing, but still there are changes in the reading, and somewhere there are like a drastic change. So why it happened? So there can be few reasons, like it can be air resistance or elasticity, or it can be a hook error, that the hook we placed in a paper, that hook can be like disbalanced or disturbed. There can be a nail error, the nails that we placed inside our board, they may be like somewhere displaced or maybe a bit weak, so they, while performing, they somewhere moved. And there can be a measurement error. So this is the end of this observation slide. So these are the observation we get while performing our experiment, and as well as the error that can occur while performing the experiment. Thank you so much.
Hello, I'm Wing Hu Zhang. So let's talk about the method and procedure for testing the hypothesis. Firstly, we need the materials below. One letter size paper, and it's about 8.5 by 11 inches. One plastic lid, two nails, one rubber band, one staple. And for the tools, we may need one stapler and one tape measure. Then we can start to make our paper plane. To make the paper plane origami, we will use the letter size paper, and the type of the paper plane is dot. So, in case you don't know how to make a basic dot, these are the steps to follow. First, fold the paper in half. And second, unfold and then fold the corners into the center line. And third, fold the top edge to the center. Fourth, fold the plane in half. And finally, fold the wings down to meet the bottom edge of the plane's body. One more important thing, we have to add staple as a hook at the head of a paper plane, and then we will use it for hooking on the rubber band while launching. And then for the paper plane launcher, we need to punch two nails in the plastic lid in parallel, and then we bunch up the nails with a rubber band. So after finishing the paper plane and paper plane launcher, so how to launch the paper plane? We need to by attaching the hook of the paper plane to the rubber band, and then pull the plane backwards as far as we can. And finally, release it when we are ready.
Hi everyone, my name is Lavish and today I'm gonna speak about hypothesis for the paper plane launcher. So let's get started. So today's agenda will be weight of the plane, distance, forces acting on a paper plane and the sources. So weight of the plane. How does a paper plane flight range depend upon the weight of the paper? So hypothesis will be because lighter material appears to linger in the air longer than the heavier stuff, the lighter paper will travel the farthest. So distance. Which plane will fly to the maximum distance? Hypothesis will be the aircraft that can fly the farthest will have the largest wings. So what is your design? The independent variable will be the shape of the plane. The dependent variable will be the distance traveled, and the control variable will be the size and weight of the paper and environmental circumstances, and the launcher for the plane aeroplanes being planes being thrown by people. So, what are the forces that are acting on a plane? Thrust, the engine, your arm that powers your aircraft, and the plane slowing down as a result of airborne friction, which is also called drag. So, the lift, the force that propels the aircraft upwards, and the gravity, the force responsible for the plane's crash. So, thank you for watching this, and these are the sources which you can refer to for more hypothesis knowledge. Thank you.
Hi everyone, this is Mehak Chawla from Team 6 from NAT 108. We are doing an experiment for paper plane launcher, and after doing the experiment, these are the conclusions which we are up to. Paper plane launcher, when we tried doing it with our wrist, it did not reach much distance. But whereas when we tried doing it with the band and the nail, it covered much more distance, which taught us that the band and the nail helps us store the energy in it, And after storing the energy in it, it can be used like to throw at a further distance, which is used at now at many places by very, like it is the basic mechanism of any airplane launcher used by any scientist. Here are the references for where we got the material from. This is a YouTube video which you can also watch, where you can learn how to make an airplane launcher. We have our own videos added to let you know. And the other link is for all the data where we learned and how we got to know about this experiment. Thank you so much, Professor, for the assignment because it was very fun working with the team and also we learned something new and developed the project from it. Thank you.